Hi, this is Nat, and this is your video lesson on making and reading scatter plots. We're also going to talk in this video lesson about different types of correlations, what correlations are, and how we can identify different sorts. Let's start off with an important question, and that is, when should we use a scatter plot? Like all graphs, a scatter plot exists to show us or help us see particular information about data. A scatter plot uses very specific data, and that is two sets of numerical data from the same source. Here's what I mean by that. Let's say we're trying to find out the relationship between, say, somebody's height and their age. One thing we can do is we can take that data from a bunch of different people and put it on a scatter plot. And we'll see in a couple minutes that a scatter plot really lets us clearly see the relationship between two sets of numerical data. And the idea here is that we're going to take a bunch of people, and from each of them we are going to pull out those two bits of data. So from our first person we might say, oh, you're 58 and you're, I don't know, 6 feet tall, 72 inches. And from our second person we might say, oh, you're 45 and you're, I don't know, 6 feet tall almost. Maybe you're only like 70 inches. And so on, all the way down to our last person, we might say, oh, you're a baby, and oh, look, you're only like 18 inches tall. The important thing here is, again, that we are collecting two pieces of numerical data from the same source, in this case from the same person. Two pieces of numerical data from the same source. And we're going to take all those paired data and we're going to put them onto a scatter plot. Because what that helps us see is the relationship between those two pieces of data. And that's the real idea of a scatter plot. That's when we use a scatter plot, when we really want to show the relationship between two pieces of data or two types of data. In our example, age and height. We think there's a relationship. We can put it on a scatter plot to see if there actually is. So let's go ahead and do this. A lot of making a scatter plot is going to look very familiar. If you remember our line graphs and our bar graphs and all those other things, when we're dealing with anything with a scale, we're looking for consistency. So we want consistent spacing, consistent counting. Now, there is a difference here because you don't have to space and count by the exact same thing on a scatter plot's two axes. So you might have a different counting and spacing system for your y-axis than you have for your x-axis. But you do have to think it through and be consistent. Now, both axes are going to begin with 0. So here's 0 down there at the origin, the corner. That's still the case. And let's start here with our age data, and then we'll move on to our height data after that. I see that I gotta go all the way from 1 to 48 here, so maybe counting by 5s is a good idea. So I might space by 1, count by 5s. So I'll put in my spaces first, just like usual. Make sure those are evenly spaced before I start numbering. And I already made the decision not to use a scale break because I am starting with 1 down here. And since Nora is only 1 year old, there doesn't really seem to be much of a point in putting a scale break to 1, especially if I'm counting by 5s. So I'll just go ahead and start. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and that gets me high enough, so that's about right. Okay, moving on to the next axis. Now we're going to take a look at our height axis. That's our second bit of numerical data, and I again have to make a decision about how I'm going to scale that. In this case, it looks like this one has to go a little bit further. My lowest piece of data seems to be this 23 right here, and my highest piece of data seems to be this 73 at the top. So again, I'm going to choose not to use a scale break because I'm making a pretty big jump from 23 to 73. That's like 50. And so anything, jumping to 23 and then counting by a high number isn't going to do me a whole lot of good. So I'll probably I think in this case, let's see how many spaces I have to work with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spaces. So if I counted by fives, I would actually make it. So I'm going to do that. So again, 5, 10, 15, 20. And I could write these sideways if I wanted to make things a little bit easier. It's kind of getting cramped in here, so I might go back and actually fix that. So this is probably a good thing for some of you all to see. A lot of times, especially if you're writing names or something like that, that's a little bit longer and you're kind of running out of space trying to write sideways, a good habit is to just turn the graph sideways and number your scale or label your scale sideways, particularly on that x-axis, the horizontal axis. And almost done. 50, 55, 60. Oh, I ran out of room. Miscounted. Alright, trying it again, I guess. This time maybe we'll count by 10 since we couldn't make it with fives. And there we go. That got the job done. So now it's time to actually start placing our individual pieces of data, and I'm going to put a dot at every place that it represents a person. Now it's important to recognize that even though this chart gives names for all the different people, when I put these on the scatter plot, I'm going to lose the names. I'm not going to know whose dot is whose, because I'm not going to take the time to label that, because that's not the point of the scatter plot to start with. The point of the scatter plot is to see the relationship between age and height, not to know whose age was what and whose height was what. That's not what we're trying to get out. So remember, when you're making a scatter plot, a lot of the times you're going to lose a little bit of data from, what you might have started with. In this case, I'm going to be losing my name data, that categorical data, because that's really not what I'm trying to do here. So we'll start with Ted, and Ted is aged 48 and has a height of 73. So it would really help if I had labeled my axis. I've done a color code, which is a little bit helpful, but I probably want to go back and label. Because one, we should always label our axes, and two, mixing up the two different bits of data is one of the most common mistakes to make on a scatter plot. So for Ted, 48 and 73, I'm going to find 48 on my age scale. I'm going to say that's maybe right about here. And then I'm going to find 73 on my height scale, and that's right about here. And I'm going to put a dot at the place where they meet as close as I can figure it. That's going to be my Ted dot. I'm going to do the same thing for Art. 45, 69. So I'm going to find my 45, which is easy. I'm going to find my 69, which is also pretty easy because it's just a little less than 70. And I'm going to put a dot in for that one. Okay. Now I'm going to do Nat. I'm going to find my 34 dot for age, which is just under 35. And I'm going to find 72. And I'm going to put a dot maybe right here. Okay. Next, I'm going to do Gus. Let's see, he's pretty young. He's under 4. So then I'm going to put a 36 in for him. 36 and 4. Maybe he lives right about there. Hard to do this on the iPad, but that's okay. And then I'll fill in the rest the exact same way. And that is going to be what my scatter plot looks like. Ideally, I'd have a little more data. More data, particularly for a scatter plot, makes things a little nicer. But you can already start to see a relationship here. And it's probably a relationship you expected or even noticed from the table before, but it's nice to kind of visualize that with a scatter plot. If you notice, our data begins low and left and sort of travels in a group like that. So up towards the right. That's an example of what we call a positive correlation. And we're going to take a second to talk about correlations in just a second. This graph is pretty well done. I'm going to go ahead and actually remove this trend line. You don't always put a trend line in. Definitely not totally necessary. We can see the correlation without it. But the thing that's definitely going to need to go in here is a title. And when you're titling a scatter plot, remember, a scatter plot is always there to show you a relationship between two bits of data. In this case, we're looking at age and height. So I might title my scatter plot the relationship between age and height. And now I can be done. That gets us to the idea of the different types of correlation. What we just saw was a correlation that looked kind of like this, where the dots in our scatter plot are gradually moving up and to the right. This is called a positive correlation. And what it means to have a positive correlation is that the data is moving together. It can be scattered to some degree, but the idea is that it's moving in the same direction. It's you've got one going up and the other going up, or you've got one going down and the other's also going down. So it's an indication that, for example, in the height-age scatter plot, that height and age are positively correlated. They both go up together, they both go down together. The opposite is a negative correlation, and in a negative correlation we see the data traveling in the opposite direction, so down and to the right. That's a negative correlation. And in a negative correlation the data moves opposite each other, or in a different direction. So to illustrate, one piece of data might be going up while another piece of data is going down, or the opposite. One might be going down while the other goes up. And this graph here shows us a negative correlation. When our data is high on the x-axis, high above the x-axis, it's really close to the y-axis. And when it's really far away from the y-axis, it is really close to the x-axis. The alternative is, again, that positive correlation, where we see that when the data is low, it's low on both axes. When the data is high, it's high on both axes. So again, things are moving together in a positive correlation and in opposite directions in a negative correlation. Some examples of data that we'd expect to get us a positive correlation might be, like we saw before, age and height. As people get older, we expect them to get taller. An example of something that might get us a negative correlation might be number of hours of exercise and somebody's weight. We generally expect that as people exercise more, their weight goes down. And as they exercise less, their weight goes up. So those things are moving opposite to one another. We could also think about the strength of a correlation. A really strong correlation is going to have all the dots in a much tighter line. So, for example, if your data were to look like this, that's a really strong correlation. That's a very straight, tight line that we've formed there. That's not typical. As things start to move out and be a little more random, we start to see our correlation get a little less strong, but still a decent correlation. If we keep going, we start to see less strong correlations. And then finally, if your data appears just to be completely random, we get to the point where we actually have no correlation. At this point, we start to see that the two bits of data that we're looking at have no relationship to each other. So for example, your height and your score on a test might be a no correlation situation. We don't really expect that your height affects your test score. We would expect the scatter plot of those two things to maybe look kind of like this, where our dots appear to be random. And that's pretty much it. So here are your practice problems for the lesson. I'd like you, for each of these two charts of data, to make a scatter plot for each one. So the first one compares different weights of people and the number of calories they eat per day. And the second one is the number of hours a group of people studied for a test, and then their test score. So make a scatter plot for each one, make sure it's well labeled and all that, and then finally tell me the type of correlation you think that is at the end. Alrighty, good luck.